All right, so we're going to continue from where we ended. So the second part of the lesson was to learn about postulates. So postulates are accepted facts. They're like the building blocks of geometry. You don't need a proof to prove these things. It's just they're so logical that we accept them to be the truth. So the first one is that through any two points, there is exactly one line. So try drawing any 2 points. There will always be just one line that can be connected. You can't draw like this, it won't connect it, you won't connect it. The only way to connect it is that one line. The second one is if two, the keyword is distinct lines, intersect, they intersect at exactly one point. So again, we're not talking about infinitely many solutions. It's if two lines intersect, there's only one point that they meet at. So if you remember from Algebra 1, like if you have system of equation, you have 3 solutions. If it's parallel, it's no solution. If they intersect, it's one solution. Or if they're the same exact line, there's infinitely many solutions. So going with that, if you play around with any 2 separate lines, there's only one point that they're intersected. If 2 distinct planes intersect, they intersect exactly at one line. So if you look at a room, you'll see like a wall and a floor. Look at it, it's intersecting at one line. If you put if you see a book, it hinges at one line. So we're going to try and apply these rules to this practice problem. So each surface of a box below represents part of a plane. What is the intersection of a plane ADC and plane BFG? So if we see ADC, it's this shaded part, this plane. And then I'm going to take a color, try to change the color. Let's say BFG. If you see BFG, we're talking about this plane right here. So where does that plane intersect? The intersection is right here, right? This line right here. So it intersects at line BC. The next question is, what are the names of 2 planes that intersect in BF? Okay, so let's just erase this. And so BF is here. So what are the 2 planes connected where they intersect? So let's see this. So you have this plane right here, and you have this right here. So we can say that we can pick any points over here, right? So let's say planes AEF and BFG. Remember, you can pick any 3 points. You don't have to mention all 4. It's only 3 points from that plane to label a plane. The next postulate we're going to learn is through any 3 non-collinear points, there is exactly one plane. Again, we went over it slightly. Non-collinear means not on the same line. Example 4. use the figure below. What plane contains point N, P, and Q? So if you see that, that's the bottom, this one, this bottom plane. And it's asking us to shade it, so there we go. I'm going to erase that. The next one's asking what plane contains point J, M, Q. Well, look at this. It's not one of the surface, but think about it this way. Can't you draw a plane out of these points? So it's going diagonal. It's a plane that goes diagonal, and that's connecting them. And the last question is what plane contains L, M, and N? Again, it's the diagonal plane that contains them. Alright, so I think this is it for this lesson, and this is concluding lesson 1.2, and I'll see you on lesson 1.3.